Welcome to the session 2 of AI for Cyber and Cyber for AI. So far what we have seen and left at session 1 is a security framework along with security controls for AI different models. Now let's take one example. Suppose you enroll for an HRMS service of a company which is providing software as a service. Now this HRMS software is owned by a company which is providing you a software and they are providing an AI service to it. What it effectively means is that you will provide all the data with respect to your HR policies, payroll policies, reimbursement policies, along with an option to open tickets. Say, for example, if somebody needs a letter to the commissioner to obtain a particular visa. Now, this HRMS software company has provided a chatbot which is AI based and uses your proprietary data to index and run a model on it so that it becomes easy for employees. Instead of reading policies, they can just use the chat box to query any query and get responses. They can also open a ticket by providing the information that is required to open a ticket, and they will get the ticket number. Now, with that example, suppose if you have to assess the risk of this HRMS software provider, which is providing this service in a software as a service model, maybe on the cloud, where your proprietary information is uploaded, and there is a checkbox which is provided to the employees. So let's quickly look at what are the security risks and controls that you should consider for such a model. And the same can be used for different models with different security controls. So for SaaS provider checklist, the very first thing you will have is that what is the data source? It means that whether the data that is being collected by the AI system is coming from the data source. We know that AI systems means that you have to train and provide the data to the LLM, and it follows the same model of garbage in and garbage out. If the data is not trustworthy, it is not official, it is not coming from a source which is provided by you, or a data is stale, then the LLM will learn and also provide the same output to the user who is querying via chatbox interface. So the data has to be coming from the appropriate source and the source has to be protected. And if the source is the latest HR policies with respect to reimbursement, with respect to leave, with respect to travel, then only that data source should be used to send the data in an encrypted as well as authenticated and authorized format. The second assessment should be done about tracking of this data source, which means that if we are using multiple data, specifically, say for example, if somebody queries that can I stay in a five-star hotel? Now, this particular employee is a grade 4 employee. He is authorized to stay in four-star hotels, and that is what the policy says, but does not authorize him to stay in five-star. While this is not explicitly mentioned in the policy, but just for the sake of example, this checkbox that is provided not only uses the LLM, but also uses a RAG database, which means that an external interface where the prompt can go and check the hotel that is being asked for is a five-star and whether it is allowed or not. And it returns that you cannot stay in, say, any particular five-star hotel because your policy does not allow it. Now, what do you mean by data source tracking? We know that there is a concept called as data lineage, which means that tracking and visualizing the flow of data from various stages, right from the origin to the final destination. So all the data that we are using to train our LLM model and its tuning, uh, particular providing in the right format, adding synthetic data to clear the weightages as well as to the usage, all has to be tracked. The third concept, it comes a security of this AI system itself, which means that the AI system that is being provided should be allowing users to do a set of tasks, which includes administrative tasks of learning, of providing the data, of validating the outputs, validating the logs, should be access controlled. It should be encrypted. Only authorized users should be able to see, and logs should be generated, which should be monitored. And there has to be a log retention. Another control that has to be kept in mind is about intellectual property right protection, which means that if you are providing the source of data, and if there is any particular IP or confidential or a copyright data, then that should be appropriately tagged so that it is not misused and it is not provided as an output. The fifth control is regarding logging and monitoring, wherein you verify how the third party is giving logs and also monitors the AI system and the supporting infrastructure. While the system logs are one concept, there is also the users who are running queries. And if there are bots who are trying to run queries to identify confidential information, or they are trying to trick by doing some sort of prompt engineering or prompt injection to obtain malicious data via malicious intent, then all that should be logged so that you can monitor it and you should be able to send even that data to the SIEM. Then reporting of security incidents, which means that if an incident is being detected by the HRMS software provider, then how they are going to report the incident to you and what will be your authority in terms of getting access to those logs which are stored in the HRMS software and where the logs are going to store with respect to geographical location and your right to retain those logs and do the analysis. Then you should have an appropriate service level agreement for transparency of the data, for the models that are being used, and there is no proprietary information, as well as all the interfaces that are being used are security tested. You can obtain a typical SOC 2 certification and also have certain service level agreements with respect to identifying and closing the identified vulnerabilities or over a period of time patching, as well as the availability, uptime, and compliance to regulatory requirements like fairness and transparency, etc. Then we also see a concept of called as confidentiality, which means that you should also test the input of the data source that it does not reveal any sensitive information. Just like humans can be tricked to fall prey to social engineering attacks by exploiting the trust, so the machines can also be, because they are anyway artificially intelligent. So what does it mean is that if you trick the LLM models to disclose certain sensitive information, be it a program, a bot running, or getting some sensitive information out from the query that an LLM can make to a database, then you will end up leaking certain, say, personally identifiable information or confidential information. Models are trained appropriately for the desired output, which means that confidentiality also means that we should be verifying the output. In fact, this is one of the second or the third top risk that has been identified as OWASP top 10 AI security risk, wherein the output is generally not being monitored, which means that when we are running query through either an API or through a chat box or a website or any other interfaces, the input is getting validated to the LLM, and then the LLM converts that input, say, for example, into a SQL query, and this SQL query goes back, queries the database, and then gets the output to you. But then the output is not being monitored, which means that if the source of information, which is the database, is infected or being provided with the inappropriate or inaccurate information, the same information will be served. And it can have leak of confidentiality, or it can have certain biased information like this particular product is not good and most of the reviews are not appropriate for this product, and the same output will come and we are not monitoring the output. So the breach of confidentiality may happen. Then there is another control on data storage, retention, and access management, which means that we should clearly identify the controls that the third party service provider has put on secure storage of data, whether it is encrypted and whether the keys are with the provider or it has certain uh, vault from where the key management is happening. We should also identify whether the authorized users can access the data and also the data sources from the HRMS administrative perspective, so that we follow the principle of least privilege and all accesses are logged. Also, how it is ensured the data is retained only for the defined period, be it 60 days or 90 days. Largely, it includes the logs from the application and the queries that you are making, and then how the data is disposed in a secure manner. Then another set of control comes for data integrity. Now, this is absolutely important that applied content security checks right from the user interface before the prompts go to the model for processing. Now, what does it mean? It means that whenever we run any query from the interface, be it website interface or a chat interface or an API interface, there has to be some sort of proxy which is built into it, which validates whether this input is appropriate. For example, it is not running certain keywords like robbing, or say, for example, it is not running a code. And if that happens, you can block it at that level itself. And then only these prompts, when they are identified as the appropriate prompt, should go to the LLM. And there can be human interface also as a second line of check for mechanisms that the system cannot understand, or this AI shield or a proxy can intercept that input and identify that they cannot make a decision, hence it should be sent to a human, and human can kind of train it, saying that yes, this is appropriate, and when it says no, it is appropriate, this is LLM model also learns. Then the concept is a privacy. We know that it is absolutely important that private data is protected, and personally identified information should be ideally tokenized so that that information does not go to the LLM model for training. However, in case if the private information has, because of the prompt injection or vulnerabilities where this can get disclosed, then ensuring that personal data is encrypted so that if it is disclosed, it is garbage, and both in REST as well as in transmit. And then there are separate instances for different business units created to avoid any common access to users. Then the last concept is about legal and regulatory compliances. And there are quite a few legal laws which ask the AI frameworks to be fair and transparent. And if necessary due diligence is not obtained, then there are penalties. In Europe, there are certain regulations which ask for penalty up to 30 million pounds or 30 million euros, or a percentage of the revenue. Now we jump to the second model of AI security testing. When we build this entire model of AI, right from the sources of data to the model to the DevOps and the interfaces, and if we have to test the model for the vulnerabilities, then what is the methodology that we should follow? The very first thing is to understand the application, which means that what are the use cases that this particular application is going to have, whether it's a SaaS-based application, or we are putting up a wrapper and using some public AI model, or we are going to be using the completely built model. When we are using completely built model, which means that everything right from the sources of data to algorithms that we are going to use to the model security and DevOps security, application security, API security inputs all belongs to us, and we have to test for security amongst all these risks. So once we understand the application, its use cases, interfaces, and capabilities, its integrations with LLM as well as with RAG database, etc., is required so that we can do the appropriate threat modeling of that particular application and also create abuse cases. And the second part is understanding this application attack surface, which means that can we exploit the interfaces? If there are APIs, then there are security controls around the APIs regarding authorization, authentication, encryption, tokenization, whether those can be exploited with various sort of vulnerabilities like IDOS and BOLA. Then what kind of users are there, and what whether the application is running with the least privilege, and can privilege escalation happen to capture the entire model, or we can bypass and get more than necessary privileges. We have to understand the ML pipeline, which means that what kind of algorithms are being run, where the data is getting fed, and whether there is any chances of evading the model or inferencing the model, etc. We have to identify the data sources as well as the output so that if there is a possibility of poisoning the data or manipulating the output, then we can do it. So when we identify the attack surface, which means that we are actually writing the abuse cases so that we can test all of this in an appropriate manner to call it as a holistic security testing that we have done for the model. Then we have to identify threat, means attack vectors. We have to simulate the user interaction largely with various checks and identify prompt injection attacks and various attacks which are model evasion, poisoning, stealing, or prompt attacks. I specifically would like to focus on prompt attacks because this is number one attack in OWASP top 10, wherein we call this as a close to social engineering attacks, wherein just like humans can be socially engineered to exploit the trust, the same way machines can also be. And then there can be multiple type of prompt attacks. It can be direct and it can be indirect. And when we say direct prompt injection attacks, It means that we are trying to fool the AI model by saying that you will do what I want to do, or you will run a particular type of code. And if the LLM model is trained to execute the task that a user is asking, which may include running a particular type of code, and that code then, when run, gives either additional information or confidential information out. Or we can instruct via various injection attacks the model to do something that it is not supposed to, like disclosing a particular confidential information, or the disclosing certain sensitive model related information. So this is what the prompt injection attack is when we say direct. When we say indirect prompt injection attack, it means that the LLM on the back end might be querying a particular database or a RAG, which is a proprietary database, uh, and the prompt can go to the LLM, and then LLM can send this prompt in terms of say SQL query to a database, and then return output. And if the uh, database is poisoned with inappropriate or inaccurate information, then that particular information will be retrieved using that prompt. So that's called as kind of indirect prompt injection attacks, either disclosing sensitive information or, say, for example, executing a particular task. Then once we identify the threats, we have to start testing for these different kind of models using various attack vectors. And these attack vectors can be to start with, say, some sort of LLM scanners. Like there are many scanners that are available, like Giscard, like Kerak, and we can use a lot of custom or little bit customized scanners because they are open source to run. Along with that, we can use human intelligence to test for prompts. So we can identify model stealing attacks, which means whether we have capability to reverse engineer the models or run custom script for black box stealing. Poisoning, which we have discussed that poisoning means that we are providing inappropriate or inaccurate or poisoned data in the training set when the LLM is learning, so that we can distort the output. And then there are model evasion attacks to evade the model, like we gave an example of earlier, an insurance provider. And if the model is using certain parameters to approve a particular health insurance claim, if you can evade that model, which means that you can get the approvals without following the model. Then there is model inversion, which means that we can gain unauthorized access via compromised credentials or keys, or we can infer the model based on bots and various multiple different type of prompts with one odd change, so that we understand that how the model behaves when we just change one of the parameters. There are prompt injection attacks, which reveal sensitive information and perform unexpected tasks. And then there are various network and interface related attacks like API attacks, application attacks like BOLA injections, so on and so forth. Now, once we test security test the entire AI system, then we identify the mitigations for that. And there are various kinds of mitigation which are also mentioned in OWASP top 10. Say, for example, for model extraction, there can be various controls monitoring for high number of API calls or query rate limiting, and also using some sort of signs of anomaly detection. Similarly, for model evasion attack, we can have performance scores for anomaly and test the metadata periodically, whether it is altered or not. Then there can have controls with respect to model transparency, which we can use by explainability techniques like LIME and SHAP to understand the decision-making process. Now, once we identify the mitigation steps, we report it, and then if they are implemented, we retest it. So these are a list of certain tools like Pirate, Giscard, Kerak, LLM fuzzers, or prompt fuzzers that can be used as an handy tools to test the AI models. Now that we have looked at AI security testing, one of the important component is also AI governance. Again, here quite a few tools are available to do the AI governance. We will discuss two of them. One of them is Luminova and another is Creminium. So Luminova is a tool which automate the complete AI lifecycle, which means that it has a governance engine where it can document and track the policy framework. You can allow the controls, and it has pre-built customizable framework in terms of controls, and you can test those controls. And the controls will be similar, where what are the data sources, is data tokenization enabled for private data, whether data masking is enabled, whether the data sources are trusted, where there are authentication and authorization happening, whether the data is encrypted in transit, etc. And then you can also evaluate the AI models, as per the policy, whether they are performance related issues or there are bias related issues, whether there are fairness related issues, and whether they are also performing as per the requirement by monitoring the logs and having certain user behavior analytics engine in place, and also automates the evaluation and reporting of the AI model. So you can see that it has the policy framework, the evaluation engine, and the data model and security controls. So irrespective of which AWS, which exact AI engine you are using, whether you are using the Azure ones or GCP one, or you have put up your own proprietary database or Google one, and you have provided interfaces to use them, it can all be monitored using Luminova. Then we have Cranium, which also has end-to-end AI security and trust platform. What it effectively does is that it monitors or maps the AI pipeline, and it inventory and automatically feature all the data sources along with data hygiene. It also has the capability to track data sources from the governance and give you the information about the data lineage. It can also track security risk in the data if they are not encrypted, if there is a sensitive information, by using certain regression to identify and validate the sensitive data. It then validates the AI pipeline security. It has the capability to do the vulnerability assessment. It also has a UBA inbuilt into it to identify the lifecycle events and do automated testing too. It monitors the adversarial AI security threats by active monitoring and has, we can say, partially SIM-like capabilities of generating alerts and also identifying the anomalous activities. You can visit their websites, Luminova and Cranium, and get more information and attend the demo. One of the additional security tools that I would recommend is that, and it is extremely important specifically to monitor the prompt, can be an AI Shield. And AI Shield also has a couple of tools, and one of the tool is a kind of proxy tool which can interpret all the inputs that goes before the LLM and can create customizations to or policies to monitor. So you can have keywords, you can monitor for code, and you can monitor inappropriate queries, you can monitor and also do rate limiting, etc. using AI. Now that we have looked at AI security, now let's look at certain cyber use cases for AI, which means that how cyber can use AI to improve the security posture. So these are few use cases. Uh, First use case is automation of the playbooks. We know that we have SOAR tools currently which can automate certain set of playbooks, but then this has to be programmed, and then they also act just like we program to do what they intend to do. But with leveraging the AI, it can dynamically write the playbook against the kind of malicious activity, be it DDoS or be it a particular malware. It can go and block a particular user, can disable a user, can shut down the system, depending on the threat or risk that it can see. Another use cases can be vulnerability GPT or a code GPT, which means that we can integrate them. So when developers do coding, the code GPT can interact and identify if there are vulnerabilities in the code itself so that it can be fixed. It's similar to like an ID integration that we do in DevSecOps with any SaaS tools, and the same can be done by the code GPT. You can also run it once the programming is done and the code is into the CVE or any particular databases from where it can run the scan. We can also use AI for malware and user anomaly identification or indicator of attack identification. So far, we have been using as indicator of compromise, which are either signature based, but if we make systems learn about various indicator of compromise, it becomes tuned to identify similar patterns. Major challenge is false positives, but with the use of AI and human reactivated learning and providing input, it can fine tune itself to not only detect the attacks, but also compute certain accuracy and come out as a better at detecting indicator of attacks. We can also automate SOC reporting by using chatbots instead of preparing a lot of dashboards. You can ask the chat box, and the chatbot can give you any sort of dashboard that you want. One classic example of AI can also be past data analysis, because that is what the AI systems or LLM models are very, very good at. So if we have got last 6 months or 1 year data with respect to tickets, with respect to malicious IPs, with respect to malicious codes or threat actors, And if we identify a similar activity again, it helps us giving all this contextual past information so that we can make a decision. So these can be some of the use cases that we can use in cybersecurity. There are quite a few OEMs which are also leveraging the AI in providing better security services or the product with an enhanced and accuracy. Like, for example, vulnerability management tools, providers or OEMs are also using AI to identify the exploitability and reprioritize the vulnerability and also give remediation advice if they've identified the same vulnerability elsewhere. So a custom remediation advice based on the context and vulnerability can be provided. With that, I will end here. Your comments are welcome and look forward to you in the next video. Thank you and have a great day.
Don't forget to like, share, and subscribe, and also press the bell icon to stay notified of all the future released videos. See you in the next one. Thank you.